Hey everyone, just a quick little experiment today. We are going to figure out roughly what's the density of air. So this is tricky because you kind of got to weigh the air. And there's a problem with weighing air. So usually what people end up doing is they'll just take a syringe full of air, they'll cap it, they'll put it on here, and they'll read the mass, 33.87. Heck, I'm just gonna make it even easier. I'm gonna zero it. And when I zero it, I end up getting 0 grams. Beautiful, wonderful. And then I'm gonna go ahead and push all that air out and close it up and put it right back on top. And you know what I get? The same thing. So a lot of people will go, oh, well, the air must not weigh anything. The scale must not be able to read it. Actually, it can. The problem is you know what happened? Is when we emptied it out, we let new air in the back. So yeah, we got rid of the air that was in here, but then new air that just came in from the backside and went in. So yeah, what we have to do is find a way to actually have this with no air in it. So that's not too hard to do. There's no air in it. Well, in this side right now, we just got to get rid of all this. So what I'm actually going to do is I'm going to just pull it. Okay. I need a way to actually open this. Now this particular one, I've drilled little holes in, and I have a nail here. And if I do this right, oh boy, this, by the way, is kind of painful. If I do this right, I should be able to get the nail through. So this now has no air in it. So this is now an empty syringe, and we'll zero that. Oh, come on. Are you not going to zero? Oh, the AC turned on. 1 second. So now we zero it. All right, so nothing. Now let's just let air in. Okay, now this thing is full. And it has a mass of 0.05 grams. So we've got about 0.05 grams in there. That's awesome. So 0.05 grams. I don't know what the volume is. Over years of doing this, I've always, like my hands have rubbed all the ink off. So we've got to get, what we're going to do is I'm going to put this air into here so we can see how much it is. All right, so I got a little tube. So however much air is in here, I'm just going to push it into there and we'll see how big it is. About 40, yeah, about 45. We'll say about 45 milliliters. Yeah, roughly. So 0.05 grams over 45 milliliters. Let's go ahead and do a little math here. Five cancels out. What I get? Oh goodness. 0.01 over 9. Oh gosh, I gotta do it. Oh, I don't have a dang it. I don't have a calculator. 1 second. One more time. 0.05. 0.05 divided by 45. I get 0.001111. So here, we only can really probably trust one sig fig of this. So we're going to go ahead and say about 0.001 gram per milliliter. Now compare that to water, which is 1 gram per milliliter. Water is about 100,000. That's about 1,000 times smaller than water. So quick little math here. If in water, like the particles are some distance apart, well, that means in air, the particles, we have to fit 1,000 times fewer particles in here. And this is a three-dimensional thing, which means we have 10 times more distance sideways, about 10 times more distance this way, and about 10 times more distance this way. Because of that, we should get about 10 times fewer or 1,000 times fewer particles in the same volume, roughly. All right. So what I'd like you to know is that it seems to be that air seems to have about 1,000 times less density than water, and that the particles seem to be about 10 times further away from each other in every single direction, roughly. Very, very, very roughly. All right, everyone, let me know if you have any questions. Have a nice day.